In Unit 7, we're going to talk a lot about a polynomial, but before we can talk about a polynomial and define what a polynomial is, we need to talk about exponents and rules of exponents. We need to talk about radicals and how radicals work, like a square root or a cube root. And we need to talk about the relationship that exponents and radicals have together. So you're going to see in these first few lessons us talking about how to manage and work with exponents, how to manage and work with radicals, and what that relationship is, and that's going to lead us into the idea of what's a polynomial and how do I work with it. In this lesson, our goal is to talk about how to simplify expressions that involve exponents. What are the rules? How does it work? Just like when you're learning anything new, like how to drive a car, you need to figure out what do you do first? You put the key in the engine. What do you do next? You turn it on. We need to walk through that same process in the order that applies when we are working with exponents. So in case you have forgotten, let's make sure we know what an exponent is. So in the middle of this page, or I guess towards the top, you see x to the third power. And that entire expression, x to the third power, that is called a power. But what we're looking at is x is the base of our power, and 3 is the exponent of that power. And I did not write that very well. Hopefully that's easier to read. X is the base, and 3 is the exponent. Exponents only affect what they directly touch. They only affect what they directly touch. Think about that as parentheses. So for example, if there was a number in front of this x, like a 5, that 5 does not include that to the third power. The 3 is not connected or not touching the 5, so it doesn't apply. As opposed to if I had 5x to the third power, that exponent is applying to everything inside parentheses, and we will talk more in depth about that in a little bit. So let's look at some of these rules for exponents. Some of them are going to be pretty intuitive, and some of them are going to be a little more strange. So anything to the power of 1 is itself, right? It means that we multiply 5 by itself one time, or we multiply x by itself one time. That one is not as out of the ordinary. This next one is one that a lot of people forget. Anything to the power of 0 is defined to be 1. So 1,000 to the power of 0 is 1. X to the power of 0 is 1. -2 to the power of 0 is 1. 0 to the power of 0 is not defined. You're never going to be asked a question like that. It actually says that down here. But it is just important to know, other than 0, anything else to the power of 0 is equal to 1. When we have a negative exponent, what we actually end up doing is we take the reciprocal of the part that has the negative exponent. So x to the negative first power is 1 over x. 5 to the negative first power is 1 over 5. And then the next rules are sort of my favorite rules because they're the ones that you don't totally have to memorize. You can actually get to these next rules without memorizing them. You can get to them by simply expanding it out. So something you're going to hear me say a lot in this unit is that when you forget what you're supposed to do, when in doubt, expand it out. When you're not sure what to do, you can always expand it out. These shortcuts or these rules have been created to help you become more efficient. However, if you forget, you can always go back to expanding. So what does that mean? What does it mean to expand it out? Right here I see the expression x to the third times x squared. Well, what does that mean? X to the third means that I have x times x times x. X squared means that I have x times x, right? That exponent is telling me how many times I'm multiplying the part inside by itself. Well, now really all I need to do is count how many x's I have. I have 1, 2, 3, 4, 5 x's, and that's where I get x to the 5th power. So you can expand out and just count how many x's are there. Similarly, let's do this in a different color. Let's go red. If I have something like this, x squared to the 3rd power, what does that mean? It means that I have x squared in parentheses, and I have that set of parentheses how many times? I have it 3 times. So 1, 2, 3. And then I can count how many x's I have. I have 2, 4, 6 x's total. So that should give me, and this is cut off in my notes, x to the 6th power. The next power, when I have something like we talked about up here with 5x to the 3rd, when I have something inside parentheses to the power of something on the outside, what that means is that that exponent applies to everything, and you could get that expanded out as well. But I like to refer to that as showering the power. Everything inside gets that exponent. But if you did not remember that, you could do this by simply saying, okay, I have 2y, and I have it 3 times. So I have 2 to the 3rd, and I have y to the 3rd. And the last rule I'm going to talk about here for exponents is when I have division and something on the outside, or division in general, we are going to still, same concept here, shower that exponent to everything inside. And I'm actually noticing there's one rule that is missing here, so I'm going to add it down here on the bottom. If we have division, so I'm going to put a box around it, something with the same base divided by something with the same base, like n over x to the m, we can simplify that by subtracting. So the way that I'm going to show you how this works is I could say x to the 3rd, so let's say x to the 3rd over x squared. That means on top I have x times x times x 3 times. On the bottom I have x times x, so I can divide 2 of those to be 1. X divided by x is equal to 1. I like to make that look like a little 1. X divided by x is 1. I like to make that look like a 1. So what's left is 1. And notice that 3 minus 2 is 1. So now that we've established these properties, what I really want to do is give you some simple examples and then build into some more complicated ones. So let's look over some examples. Okay, let's look at some examples. So 2 to the 3rd is really just saying 2 times 2 times 2. Well, 2 times 2 is 4, and 4 times 2 is 8. So we can say that 2 to the 3rd is equal to 8. What does 2 to the power of negative 3 mean? Well, looking up at those rules above, that means that I'm going to take the reciprocal, and that's going to make the exponent positive. So that means 1 over 2 to the 3rd. Well, we just said that 2 to the 3rd is 8. That means this is going to be 1 over 8. What about negative 2 to the negative 3rd? Well, negative 2 to the negative 3rd is going to become 1 over negative 2 to the positive 3rd. Now the numerator is going to stay 1, and the denominator is going to become negative 2 times negative 2 times negative 2, which is going to be negative 8. So negative 2 to the negative 3rd power is going to be negative 1/8. Now on D, there are no parentheses the same way that there were on C. So what this really means is I'm taking negative times 2 times 2 times 2. So that negative sign, there's no parentheses, is not impacted by 2 to the 3rd power. So I'm really multiplying 2 times 2 times 2, and then I'm making it negative. So D is going to be negative 8. So for these next 2 examples, I am not only going to work through these problems using the rules, but first I'm actually going to do them the long way using the expanding idea. Because when in doubt, expand it out. That's a strategy that I really don't want you to forget, because it's a great tool to fall back on when you get stuck or when you forget something. So I have 3x squared y all to the power of 3. That means that I have 3 times x times y. And I have that a total of 3 times, because that's what the exponent on the outside is saying. So 3 times x times y, 3 times x times y. Now I'm going to simplify this. If I multiply 3 times 3 times 3, well, 3 times 3 is 9, and 9 times 3 is 27. Then I'm going to count how many x's I have. Well, I have 2, 4, 6 x's, so 27x to the 6th. And lastly, I'm going to count how many y's I have. 1, 2, 3 y's, y to the 3rd. So that is the expanding it out. I took what was there and I wrote it out, and I multiplied the numbers, but everything else I really just counted how many times is it there. You could also use the shower the power method So this is the expand method. Now I'm going to use the property version of this problem. So really what we're saying is that 3x squared y all to the third power, we're going to shower this power. So this is going to become 3 to the third, x to the 2 times 3, y to the 1 times 3, because there really wasn't an exponent written with y, but I know that that means that there was an invisible 1 there. And now I'm going to simplify. 3 to the third is 27. 2 times 3 is 6, 1 times 3 is 1, and we get the same answer. Either way, you're going to be expected to show a little bit of work so that we can understand where your answer is coming from. Okay, this last example up top looks very, very challenging. So let's look at it one piece at a time. And let's look at the number piece first. So I have a 2 and a 6. And even though I have multiple fractions, this is multiplication. And what happens when we multiply with fractions? We multiply all the things on the top and all the things on the bottom. So what do I have on the top? On the top, I have 2 times 6, and on the bottom, I have a 3, ignoring everything except for the numbers in front. Well, that's going to give me 2 times 6 is 12, and 12 divided by 3 is 4. So I'm going to have a 4 left over in the numerator. Now let's look at what's happening with our x's. In the numerator of the left one, I have 2 of them. I have 3 in the denominator of the one on the left. The one on the right, I have 1, 2, 3, 4 in the numerator, and I don't have any in the denominator. Anytime there's an x, both in the numerator and the denominator, we can simply divide to simplify. So x divided by x is 1. X divided by x is 1. X divided by x is 1. So how many x's are left? There are 3 of them left, and they are all in the numerator. We're going to do the same thing now with y's. So over here I have 1y in the first term on top, none on the bottom. And the second term I have none on the top, and I have 1 on the bottom. So this is really going to be these y's divide to be 1, so I'm not going to have any y's at all in my final answer. They all divided out. And lastly, let's look at the z's. I have 1 z in the denominator here and 1 z in the denominator here, so I'm going to multiply those. Z times z is going to give me z to the first plus z to the 1 plus 1, which is going to give me 2. So there is the expanding way. So go ahead and pause the video, make sure you have that down, and then I'm going to show you how to do that same problem using the properties. So I'm going to leave the answer there to make sure that we got it right. The numbers we would deal with in the same way. 2 times 6 is 12, divided by 3 is 4. Now the variables, I have x squared in the numerator, and I also have x to the 4th. So when we're multiplying like that, we add the exponents and we subtract any exponents that are in the denominator. So this is really x to the 2 plus 4, those are the 2 exponents in the numerator with x, minus 3, and it's minus because that 3 is in the denominator. Then we can deal with our y's. Try and change my color here. That's going to give me, there's 1 y in the numerator, and there's 1 y in the denominator. So that's going to give me y to the 1 minus 1. And then lastly, I have z. The first z is in the denominator, so that's negative 1. The second z is also in the denominator, so that's negative 1. And then we can combine these all together. So 4x, 2 plus 4 is 6, 6 minus 3 is 3. Y to the 1 minus 1 is the same thing as y to the 0, and anything to the power of 0 is 1. So I'm not going to have any y's. That's going to give me z to the negative second power, but in Algebra 1, we don't like to leave negative exponents in the problem, so we're going to put it on the bottom with a positive 2. So there's a handful of examples really to kind of get you started in thinking about each of these problems. Lastly, let's go ahead and look at these 4 U-tries. So I'm going to encourage you, pause the video, see how far you can get. Maybe start with the one that you think looks the most like one of the ones above. On number 1, you can leave your answer as 5 to the power of something. You don't actually need to multiply that out using a calculator. So go ahead and pause the video and see how you can do on your own. Okay, here we go. I'm going to work through each of these problems. This is really 5 to the 1 plus 3 plus 4 minus 5 plus 0. Just adding together all those exponents. Well, 1 plus 3 is 4, 4 plus 4 is 8, minus 5 is 3, plus 0 is still 3, so this is 5 to the third, which is 125. That one's not too bad to multiply out. If you wanted to do this using expanding, I have 5 times 5 to the third times 5 to the fourth. 5 to the negative fifth means that I have 1, 2, 3, 4, 5 in the denominator, and 5 to the 0 is just 1. And then I could simplify. I can simplify however many 5s I have an equal number of in the numerator and the denominator. That's going to leave me with just 3 5s left over, which is going to be 125. So don't forget, when in doubt, expand it out. When in doubt, expand it out. Okay, I'm going to erase that so that I can actually do, you know what, I can make problem number 2 fit. Let's just give it its own little space right here. Problem number 2, ask yourself the question, are there parentheses? And if there's no parentheses, what does that mean about that negative 3 exponent? Well, what that means is that negative 3 only applies to the part that it is touching, which is the W. So number 2 actually just simplifies to be 6 over W to the third power. Don't move the 6. There are no parentheses there. If that problem was originally 6W to the negative third, then it would become 1 over 6 to the third, W to the third. But that is not the way that that problem was originally set up. So make sure you're paying attention to where those parentheses are, or if they're not there, what that means about this type of problem. Okay, number 3. Option 1, shower the power. That's going to give me 2 to the 4th, x to the 4th, y to the 3 times 4. 2 to the 4th, I would expect you to simplify, is going to be 16, x to the 4th, y to the 12th. And then, as always, when in doubt, expand it out. Let me just show you what it would look like to expand it out. So if you can see above the problem in blue, I actually expanded it out. So now I'm saying 2 times 2 is 4, times 2 is 8, times 2 is 16. I'm counting my x's, 1, 2, 3, 4. I'm counting my y's, 3, 6, 9, 12, and I get to the same solution. Similarly, on number 4, you could expand it out. X times x, 1, 2, 3, 4, 5 y's over 1, 2, 3, 4 x's, 1 y, and that b to the negative 2 means that those 2 b's are going to go to the numerator, and then I can simplify anything that simplifies. That's going to leave me with y to the 4th over x squared, and there's also going to be a b in the numerator. Now let's look at that using properties of exponents instead. X to the 2 minus 4, y to the 5 minus 1, b to the negative second would give me x to the negative second, which means it's going to go in the denominator, y to the 4th b. So we get the same answer. My 4 was kind of hiding there. So the big ideas, the key things from this section, knowing and understanding how to manipulate and work with those powers of exponents, remembering the most important expression of today, when in doubt, expand it out. And I hope you remember me saying that in a really silly voice. So practice using those properties. Make sure you memorize the ones that you feel you need to memorize, and make sure you remember, when in doubt, expand it out. Looking forward to supporting you on this in class. Thanks for listening.